next lecture, we'll discuss the rules of associativity for our rule set. We're going to abbreviate that with the abbreviation ASSOC. Please do not use the abbreviation ASS. That's terrible. Okay, so associativity. In Chapter 6, they talk about associativity for and. That's a terrible ampersand. For and for or. Let's start with and. So associativity for and says that if you have P and Q and R, where Q and R are grouped together, because remember we always have to have parentheses here because we've got two main connectors, that we can move those parentheses and we won't change anything. So instead we could group together P and Q and have R all by itself. And we can go both ways. So your text calls the one over here associativity left and this is associativity right and. I don't care about these rights and lefts, and I don't care about the and part. You can just say it's associativity, and I'll figure out that it's for an and statement because I'm clever and can see that it is an and statement, in fact. One thing to note is that with associativity, notice that all the connectors here have to be the same. So you can't have, like, say, ands and ors. You couldn't have, say an or in here and do associativity. Then it's right out. There are going to be some rules that let us play with formulas like that, but it's not this rule. Okay, let's talk about associativity of or. So, associativity of or. So if you have P or Q or R, where Q or R are grouped together, then you can move those parentheses so that P or Q are grouped together and R is separate. And this can be a handy rule sometimes. So they call this one associativity right or, and this is associativity left or. I don't care about those. In fact, I can't even really think to explain why. One is right and one is left. I don't know. I don't use those. In the software, I just kind of play with them until I get the one that's right. Okay, so that's really all there is to that. Okay, now I want to talk about another type of associativity that isn't mentioned in your text at all. So it turns out that the biconditional is also associative. So if we have P double arrow parentheses Q double arrow R, we could move those parentheses if we wanted and create P double arrow Q, put that in parentheses, double arrow R. Sorry, that was kind of terrible. Let me rewrite that. I'm taking up too much space. This will be better. Okay, let's get rid of this one. So you could sit down and it wouldn't be a bad plan to sit down and do a truth table for these, just to sort of prove to yourself that they are associative. I will, unlike the other derived rules, you'll notice if you look back at your homeworks for the basic rules and for particularly when we got to the rules requiring assumptions, I was having you prove a lot of these derived rules. And I'll talk a little bit about the motivation behind that in another lecture. But I'm not going to make you prove this one because the proof is terrible. You don't ever want to do this proof. It's nasty. I will post, I have a proof written out of 1/2 of, I can't remember which direction it is, if it's from P, if and only if, parentheses, Q, if and only if R, close parentheses, or if it's the other way around. And it doesn't really matter because the proofs are basically analogous in either direction. So one should be sufficient for you to see. And I'll post that proof and let you look at it. And if you like, you could generate the other half for your own fun and amusement. I'll leave that to you. But this isn't a rule that comes in handy a ton. It doesn't really come up a lot that we want, that it would be useful to move the parentheses. However, when it does come up, it's useful having it as a derived rule because, as I said, doing the proof using just the basic rules is pretty hairy. You know, it's probably some 30-some lines long. I'm not sure. So you don't want to do that. If you ever need to move the parentheses, you want to be able to just do that. And that's why I'm giving you that as a rule.